What is the converse of the Pythagorean theorem? Have you ever wondered how we can determine if a triangle is a right triangle just by knowing the lengths of its sides? This is where the converse of the Pythagorean theorem comes into play. Let's break it down together. The converse of the Pythagorean theorem states that if the square of the length of the longest side of a triangle equals the sum of the squares of the other two sides, then that triangle is a right triangle. In simpler terms, if we have three sides, let's call them side A, side B, and side C, where side C is the longest, we can use the equation a squared plus b squared equals c squared. If this equation holds true, then the angle opposite side C is exactly 90 degrees. Now let's compare this with the original Pythagorean theorem. The original theorem tells us that in any right triangle, the square of the hypotenuse, which is the longest side, equals the sum of the squares of the other two sides. The converse flips this idea around. Instead of starting with a right triangle and figuring out the relationship between the sides, it starts with the lengths and determines if the triangle must be right-angled. This converse is quite handy for identifying the type of triangle based on side lengths. If a squared plus b squared equals c squared, we have a right triangle. If a squared plus b squared is greater than c squared, the triangle is acute, meaning all angles are less than 90 degrees. If a squared plus b squared is less than c squared, the triangle is obtuse, meaning one angle is greater than 90 degrees. By applying the converse, you can check whether a triangle is right-angled just by measuring its sides. This is particularly useful in fields like construction and navigation, where verifying right angles is essential. You do not need to measure angles directly, which can sometimes be tricky. So, the next time you have a triangle and want to know if it has a right angle, remember the converse of the Pythagorean theorem. It provides a simple way to confirm the presence of a right angle using only the lengths of its sides. This method is a practical tool in geometry that makes understanding triangles much easier.